So we have now learned several ways to factor. We know how to take out the GCF. We know how to group 2 and 2 to factor 4 terms. We know if there are 3 terms that we would use the AC method, and we know how to recognize the difference of squares. And hopefully you're convinced that these are all pretty easy in themselves. All right, so now what we're going to do in this lesson is we're going to have to put them together. And the hard thing is going to be to decide what do I do when. And this is a flow chart here on the first page to kind of step you through it. It looks like there's a lot there, but it's really fairly simple. So the very first thing you're going to do is you're going to ask, is the polynomial in standard form? And if it is, then you're just going to continue. If it's not, you're going to put it in standard form and then continue. And just like we've discussed before, the very first question we're going to ask as we begin to factor is there a GCF? And if there is, then you're going to factor it out. And is there a GCF that needs to be factored out? This should be a yes, right? So if the answer is yes, we'll go that way. And if it's no, then we'll go this way. So yes, factor it out and then come here. No, just come on here to the next spot. So the next thing we'll ask is we're going to count the terms. That's what I would say, count the terms. If there's 2 terms, so it's a binomial, then we're going to ask ourselves, is it the difference of squares? And if it's the difference of squares, yes, then we're going to factor it. And if not, then we're not going to factor it. If it's 3 terms, then we're going to ask, we're going to do the AC method, so we're going to give that a try. And if there's 4 terms, then we're going to group 2, and factor it. Now remember, not everything will factor. Most of everything we're going to be doing will factor because that's the whole point. But not everything factors in the real world. And again, once we do all these different factoring methods, we'll look at our answer and ask ourselves, is there still a difference of squares? And if the answer is yes, then we're going to factor it and then come back around and ask ourselves that again. And if not, then we're going to stop and we are done. All right, so the next thing we're going to do is just try this out on a few examples. All right, so for example 1A, I've kind of written over here just a real simple. First thing we're going to look for is standard form, GCF, and then we're going to count the terms. All right, so here, 81A minus a to the 5th. So standard form would mean that this needs to be in the front. So that negative is going to travel with it. Now I'm going to have a negative a to the 5th subtract 81A. Now I'm going to look for a GCF. I see that there's an A in both terms. So I'm going to take out an A. And because the front term is negative, I'm going to factor out a negative A. So I'm going to factor out a negative A GCF. And that's going to leave me with a positive a to the 4th. And negative over negative is positive. 81A over A is going to be 81. Oops, this is a mistake. This should have been, when I factored, no, that's right. This should have been a plus here. I'm sorry. That should have stayed a plus because this was a plus. And then when I factor out the negative A, then this is going to be negative right there. All right, so then once I factor out the GCF, negative A, I'm left with the a to the 4th minus 81. I'm going to then count the terms, 1, 2. And because there's 2 terms, I'm going to ask, is it the difference? Well, yes, it is a difference. This big ugly thing right there is a minus. So minus, this is a perfect square, and 81 is 9 to the 2nd power. So I'm going to factor that as the difference of squares. So I'm going to have a to the 2nd times a to the 2nd. That's going to give me a to the 4th, a plus and a minus, and then 9 times 9. All right, so that I feel pretty good. I factored twice, but remember our instructions say look at our answer and determine if either of our factors is a difference of squares. Well, this first one is not. It's a plus, so that's not a difference. But I come here, this is a difference. Well, that's a square, and that's a square. So this factors, again, is the difference of squares. So I'm going to rewrite negative a, that's going to stay, a to the second plus 9, and then this is going to become 2 parentheses. There's my a times a, my plus and my minus, and then 3 times 3. So now when I look at it, there is a difference here, but these are not squares, so I can't factor it anymore. So here is my answer.